All right, so in this lesson, it's 4.1, chapter 4 here, trigonometry and the unit circle is what we're studying in pre-calculus 30. It's 4.1 today. All right, I gave you a worksheet to fill out. This is what the worksheet looked like, and we're going to kind of go through it. And I wanted you to sort of, after our exam in chapter 3, to work through 4.1 on your own. So you should have most of these terms. You should know most of these terms already from your study and work on the sheet. So what I want to go over here first, thank you, is an explanation of what a radian is. Okay, so I clipped this from the textbook for you, which talked about what a radian looks like over here. Right, this is a radian on the diagram over here. There's some information here. One full rotation is 360 degrees, or 2 pi radians. So there's a major connection right there. One full rotation around anything, 360 degrees, is the same as 2 pi radians. So right away, what you want to see is that radians is a different way of expressing angle measure. Okay? It's another unit. It's just a different unit. And it's not based on, 360 little parts of rotation. It's based on something else, and it includes pi. Now, you may also have gathered that the distance around a circle, the circumference, is 2 times pi times r. I don't know if that came to mind at all, but that's pretty interesting. That 2 pi, okay, is part of that formula. The circumference, obviously, is one full time around the outside of a circle, and the radius is sort of how big that circle is, right? So that's very interesting. So let's just keep that under our hat here for now. A half rotation, 180 degrees, is 1 pi. Well, that makes sense. A quarter of rotation, 90 degrees, is pi over 2. So 1/2 pi, and so on. 45 is pi over 4. So these are some important connections that you're going to have to make. But what is a radian? In your own words, what is a radian? So, okay, so we have different ideas about what a radian is, and some of you said some good things. So some of the things that were shared here, that a radian uses pi to explain its rotation, which, yes, that's a very good observation. Excuse me. But we don't have to have pi in our radian measure, but that is quite common, so that's good. Someone else said that a radian is 57, about 0.3 degrees, which is absolutely true as well. Not really a full definition of a radian, but you're on the right track. So I did include this definition from the textbook, hoping that you would sort of build off this. And we did have one attempt to kind of just basically say this in your own words. So some of you were asking me about subtended the other day, right? When I gave you some time to start this, and I wouldn't tell you what subtended means. I wanted you to look that up. Did anyone look up subtended and are able to explain it to the class here right now? Okay. Are you serious, you guys? You were all asking me what subtended means. I said look it up, and no one looked it up? Really? You weren't allowed on your phones during class. Yes, that's true. But did you have any, were there any minutes of the day between the end of last class and the beginning of this one? I'm not sure. Was there? Do you guys know what the World Wide Web is outside of your phone? Do you know what that is? The interweb. You know what that is? You can go to a computer, look things up. You can look things up in a dictionary. They actually have dictionaries as books. Did you know that? Yes, I'm being a little facetious here. Okay, so again, I'm going to get back on my soapbox here. You guys are in grade 11, okay? So you guys need to pull up your socks a bit, okay? Explain in your own words. Not many of you actually did that. You are all asking me about what subtended means. No one looked it up, okay? Because you're all thinking he's going to tell us anyways the next day. I'll just let him do it. We need to kind of change our thought process a little bit here, all right? This is your education, not mine. Okay, all right. So, subtended. What does subtended mean? Okay, it sort of means like cut. Okay, it's a portion of the circle that's cut by the arms of the angle. Subtended. you think about sub, that means under or within, right? A subcategory. It's another category within another category. So 1 radian is the measure of the central angle subtended or created or cut from the circle that has an arc of the same length as the radius. So one of you sort of attempted in your own words to say that a radian would be the angle here, okay, that makes a section of the circle the exact same length, the curved length, as the radius. Okay? So again, in another way to say that, you might want to say 1 radian is the angle that is created by 2 arms extending from the center of a circle, or by 2 arms of the angle, that cuts the circle in such a way that the arc here is the same length as the radius. So what's important here is that these 3 pieces, so this is a curved length here, this length right here is the exact same length as the radius of the circle. Okay, and that's how 1 radian is defined. Okay? And yes, 1 radian is approximately 57.3 degrees. That is true. But it's not the definition of radian, it's what 1 radian equals in degree measure. Okay, so there's a difference. All right. Okay, again, individual assignments. You guys got to kind of get used to these. If you head to university or post-secondary, okay, there's going to be a lot of times where the prof just says, hey, know this chapter for next class, or know these 4 chapters for next class. We're going to be talking about them, and I'll expect you to contribute. Stuff like that. So this was kind of my attempt at kind of guiding you through an exploration of this section. So 1 radian this is where you want to fill that out, 57.3 degrees. Okay. All right. Now, I don't know which way you went here. I don't know. Do you guys have this on your sheet? Did I add this later? What's the difference between a positive angle and a negative angle in standard position? I think I asked you to put that on your sheet there if it wasn't on the original copy. So, what's the difference between a positive angle and a negative angle in standard position? Anybody? Yeah? Okay. Okay, negative is drawn clockwise. Okay, from the positive x-axis, we should probably say. Okay, from positive x-axis. What does that look like? Well, here's the x-axis, here's the positive portion right here to the right, and the of course the vertex of the angle there is at the origin. And so if it's drawn clockwise down this way, that would be a negative angle. That's correct. So in standard position, the initial ray, okay, of the angle, that's the initial arm or the initial ray of the angle, is on the positive x-axis. The vertex is at the origin. And the direction of opening is sort of like, it's clockwise. That's a negative angle. Very good. And so positive angle, of course, would be the opposite. Okay, positive is drawn counterclockwise. With all of the same thing. So vertex at the origin, initial arm, initial ray on the positive x-axis, and then it's drawn in a counterclockwise direction. Okay, and that's positive theta there. Now, can we have an angle that's greater than 180 degrees? Yes, we can. Can we have an angle that's greater than 360 degrees? Yeah, we can. How far this goes here, okay, it doesn't have to stop anywhere. It can keep going round and round and round. If it goes around 2 full times, that's 720 degrees. No problem. What is that in radians? 2 full rotations in radians, then, is what? Yes, very good. 4 pi. It's 2 times 2 pi. That's 2 full rotations. Okay? And of course, you can have fractions of that. Now, in radian measures, someone had mentioned that a lot of times the pi is used to write radian measure, and that's totally true. 1 pi is 180, and then pi over 2 is 90. Well, we could have 3 pi over 4 as well. 3 pi over 4. 1 pi over 4 is 45 degrees. So what is 3 pi over 4 in degrees? 100. 45 times 3 is 135. Right? Okay? So, of course, we could have, we could have 33 pi over 4 too. So we could have big, big angles as well. All right? It's good. Converting radians to and from degrees is easy. Now, this was not in your textbook like here in big bold letters, this is the ratio. But did you see it? Did you figure it out? What is the ratio that we could use? What are the two ratios that we could use to convert? Because it would have been in some examples there, and there's a note, I think, in one spot for sure on page 169. Anyone get it? Yeah. Yes, very good. Very good. 180 over pi, or 180 divided by pi, and pi divided by 180. That's right. So really it's the same ratio, just the inverse. One is the reciprocal of the other, I should say. And so yeah, these are the two basically conversion factors between radians and degrees that we can use. Now on your calculator, you may be able to find a function on your calculator, and all your scientific calculators should have it, where you can actually convert degrees to radians just on your calculator with a push of a button. The only problem is that it will always give you an answer in decimal form, and we're going to want to explore exact values, okay? And we'll talk about what exact and approximate values are a little bit later. All right, so how can you tell which ratio to use? This might be best explained using examples. I'm not sure. Maybe you don't want to write a sentence here, but I did leave some space. And actually, I think I might just take those out so I can write or draw or whatever I want to do there. So how can you tell which ratio to use? Well, if you're going from radians, if you've given radians and you're going 2 degrees, and we're going to multiply by one of these two. Let's say I have pi over 4 radians, and I want to know how many degrees that is. Which one of these do you think would I use? 180 over pi or pi over 180? You think 180 over pi. All right. Now, why did you say that? Can you explain that in words? Okay. So you were thinking of unit analysis, very good, and how the units maybe on top here would divide out with some units on the bottom. Yeah. You want to get rid of pi. I mean, not that pi is bad. I like pi. But you want to be able to get rid of pi to simplify, just the numbers, because degrees, right? Not often do they have pi in there. So if you want to get rid of pi to go to degrees. So what's 180 divided by 4? Well, that's 45. So you simplify that, 45. So that's exactly right when you're going from radians to degrees multiplied by 180 over pi, so you can eliminate the pi constant. Okay, and of course then degrees to radians, right? You're going to multiply by pi over 180. So if we have, let's say, 135 degrees, we talked about that one already, we're going to multiply by pi over 180. So see how the degrees will cancel out there? We're going to get rid of degrees. We're going to end up with radians. Now, 135 pi over 180. You might be tempted just to get on your calculator and find a decimal number, but again, you're in pre-calculus 30, and so one of the things that we're very interested in are exact values, which means that we want to write our answers in terms of fractional parts of pi. We don't want to turn pi into a decimal, because it's an irrational number, so to be exact, we're going to leave pi in our answer. And we don't want to write a decimal times pi. So we just need to, what we need to do is reduce the fraction. Okay? So what does this end up to be? Well, 3 pi over 4, or 3/4 pi. That's right. We divide both by 45. All right? Any questions so far? Yes, no, does that help clarify something? So if you have questions while we're going through, please feel free to ask. I know I got after you for not doing some of the first stuff, but if you have questions, please feel free to ask. That's what I want. I want to make sure we get through this. All right, what are coterminal angles, anyone? What did you write down for coterminal? Okay, you're doing it first. Okay, the angle is greater than 360, so you can see how many times it rotates. Okay, reference angles. Okay, so you're kind of, yeah, centering around. Do you have anything to add to that? Okay, angles which have terminal arms which coincide. So in other words, okay, when the angle is done, the second arm, right? If we have an initial arm here, right? The terminal arm is kind of what finishes off the angle. And so if we have two angles that are coterminal, they would end at the same spot. So they don't necessarily have to start at the same spot, but in this case, I have two angles that end on the exact same spot. So this angle here, theta, and this angle here, negative theta, those would be co-terminal. So co, right, if you're talking about co-pilots, right, it means kind of two people sharing a duty or something, or two things together. And terminal means that's the terminal arm. Okay? So two angles, yeah, if you want to write this down, it's two angles in which the terminal arms coincide. Where they both end at the exact same place. And yeah, it was mentioned that if you go another full time around, you get a coterminal angle, something like that. And yes, that's true. If this is theta 1, you could have another angle, and I know this is kind of small, but if you went there and then all the way around once more, yeah, you could have a coterminal angle, which is actually going to be, we're going to explain, that's what this next question is actually, right here. What is the general form for any coterminal angle? Well, if you have any angle and you add or subtract a full rotation, that's a general form. And any full rotation times any number, number of full rotations, okay? Where n is, well, n would be, if you're doing plus or minus, n would be whole numbers, I guess. Okay. In radians, plus or minus 2 pi times n. Okay. So that's quickly how you could find another coterminal angle. If you're given an angle of 60 degrees and you want to find another coterminal angle, you could just add or subtract 360 to that and be done. Right? So you can say, well, 420 is a coterminal angle. Okay, so that's 360 plus 60. What is a reference angle? Remember what a reference angle is? If you have an angle theta like this, what's the reference angle? Okay, the reference angle, yeah, is the acute angle that is formed from the terminal arm of an angle to the nearest x-axis. So it's always an acute angle formed by the terminal arm of theta and the x-axis. Okay. So it would be theta minus 180 to get to your terminal line there. In this case. Next question, what is arc length? We talked about arc length at the beginning. What is arc length? If we have a circle and we have an angle, central angle here, theta, the arc length, the arc that is subtended by this angle, would be here. It's the section of a circle. It's like a curved surface along the outside of the circle. Is the length of the arc. So think about, you know that term, arc. It's something that bridges across, so it's kind of got that rounded sort of connotation to it, right? If you throw a ball, it forms an arc. The path of the ball forms an arc. It's curved. An arch is a curved, something like that. A bridge is made in an arc length, an arc shape. So this is an arc. An arc length is a section of the perimeter of a circle. You can put it that way if you want. Section of the perimeter of a circle. You should have noticed a relationship between arc length and theta, that's the central angle that forms that arc, and the radius. So hopefully everybody got this one. How does one determine arc length? A equals what? What's the formula? Theta times r. Yes. Very good. Now, theta, can that be in degrees or radians? Does it matter? Degrees? Okay. What do you think? Look at your examples there. See any notes in your textbook there? Arc length. Okay, so here's the page in the textbook that talks about arc length of a circle. And it does say at the bottom, this formula, A equals theta r, works for any circle, provided that theta is measured in radians. And both the arc length and the radius are in the same units. So just to explain arc length a little bit further, guys, here, watch this. If we have an angle theta, and we have a radius of, let's say, 1, then the arc length will be the length of x from A to B. See that? But if the radius gets bigger, then the arc from D to C is bigger. Right? Okay? So as arc length gets bigger, as the radius gets bigger, the arc length gets bigger. Right? So it would make sense that if you have the same angle and you have a bigger radius, you have a bigger arc length there. So A equals theta times r, and theta must be in radians. Yeah. So we'll want to put that down here as a little note. Theta must be in radians. I think it makes sense too that A and R have to be in the same units. All right, this question was a bit abstract. I wanted you to kind of think about this next one. How does this formula relate to the definition of 1 radian? Okay. So how does this relate to the definition of 1 radian? Did anyone sort of see the connection there between that formula and the definition of a radian? So let's go back to our definition of a radian. A radian is what? The angle, right, that makes what? The arc length equal to the... It makes the arc length equal to the radius. See that? And so if this is the case, what is theta? Well, here theta would be equal to 1. So here's the definition of a radian, right here. And there we can see that the formula, when you rearrange the formula, theta equals 1. And of course that's in radians. Now you might see this, a capital R, as an exponent. I'm not sure if that's if you see that in the textbook or not, but you might see that. Generally there's no units for radians. Okay? Generally it's just a number, an angle measure and a number with no units means radians always. But sometimes you might see a little R, okay, or 1 radian. You might see 1 rad, something like that. And consequently, on your calculator screen, if you have rad on your calculator screen, that means your calculator is dealing with an angle measure in radians. So rad and DEG, degrees, now you know what that difference is, okay? All right, sorry, question? Right here, the original formula is A equals theta times R. What happened to the R in the second one? The definition of a radian is the angle that makes the arc length and the radius equal. So that's A and A. They're the same. It can be, you can put any variable there, but they're always the same. So that's what a radian is defined as. And so if you rearrange that or manipulate that formula, you get theta equals 1. Right? So that's sort of how that's related. That's why this formula exists, and that's why it works. It all kind of fits together. So that was my question. So if you let A and R equal each other, being anything, you could have put X here and X there, then you end up getting theta equals 1. Okay? So yeah, I'll let you think about that a little bit, okay, and let that sink in for you. But that's where the R went. All right, so finally, I think this might be the last thing on your page here. What is the difference between an exact value and an approximate value? This is going to be very important going forward in this class and in calculus. An exact value, yes, has more precision. It's more exact than an approximate value. Approximate with kind of think of a rough estimate, right? An exact value is as precise as possible. So when we're talking about angle measures, okay, for example, if we take, well, let's take any example, like 0.3 versus 1/3. Okay, which one is more exact? Well, yeah, 1/3, because 1/3, if you do that on your calculator, you get 0.3 repeating, right? So this is exact, and this would be an approximate value. So another example, we're talking about an angle measure of pi over 4. This is exact, and this is approximate. Because pi over 4 means this whole decimal, and as a matter of fact, however many decimal spaces we could see on the calculator, it would just keep going on, right? It's irrational. So this right here, pi over 4, it carries with it the infinite number of decimal places if you write it as pi over 4. That's exact. As soon as you write the decimal, you have to round it somewhere. See how I rounded it here? 0.785. I rounded it here. So that, as soon as you have to write a decimal and round it, if you have to chop off some of the decimal places, it's not exact anymore. Okay? So in dealing with calculus, we are interested in exact values. So that's why we write a lot of our answers in fractional form, especially, root 2, okay? We write root 2, right? We don't write whatever that is, 1.4, whatever, okay? We write it here is in exact form. Thank you, Mrs. Martins. Yeah, I do. I'm just going to eat it later. All right, any questions? Any questions about anything on the paper? That was your individual assignment, which I saw most of you madly scrambling the answers as I wrote them down. We'll get better at this. Okay. Any questions? Okay, that's your intro to 4.1. And I'm going to give you your assignment now, which is 4.1, page 175. You can do numbers 1 to 9, and do A, C, and E from those numbers, and 13.